Hello everyone and welcome back to the series on learning graph data structure. So the problem at hand is number of islands. Given an M cross N 2D binary grid which represents a map of ones and zeros, one stands for the land and zero stands for water. Return the number of islands. And what is an island? An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So no diagonal connections are allowed. You may assume all four edges of the grid are surrounded by water. And then we are given an example grid and an output. So what I've done is I've drawn the example grid on an actual grid so that we can better understand the problem. And as it was mentioned in the question that the entire grid can be assumed to be surrounded by water and water is zero. So I'm going to surround the entire grid by water. We won't do this in program. Okay, so what we have is what we know for sure is that one represent land, so it will be a constraint of island, and zero represents water. So let's quickly see how many islands we can find. The one island I can find is over here, one, four set of ones. The other island I can find is this one, and then the other one, another island I can find is right this one. And the notion that we are using island is like when the cells are surrounded on all the four sides by water. So this is surrounded by water by all the four sides. We are not supposed to look diagonally. And similarly, this is also surrounded by on all the four sides by water, that is zero. And I can do the same for the other one, last one. It is surrounded on all the sides by water. So it is an island. So that is what theoretically the question is trying to um, say when it means island, a group of ones which are surrounded by zeros on all the four sides, on all the sides. Diagonals not allowed. So the output that we have is 3, and which is the expected output. Now, how do we program this? So the idea is that what we are going to do is uh, we will we will iterate over the grid, iterate over grid. This is the grid. And while iterating, when we encounter a grid, and when we encounter this, what we will do is we will do a traversal. Can be breadth first search or depth first search. And that's it. So how the program will work? We will start by 0 comma 0, and this is 1 and it is not visited, so I will do the traversal. And in the visited I will uh, add this, I'll do traversal, I'll reach this, I'll add this to visited, I'll do traversal, I'll reach this, I'll do to add this to visited, I'll do traversal, and eventually I'll reach this node as well, so I'll add this to visited as well. And now there is no new other node possible for me to traverse. So what I will do is I will simply follow along the grid and find the other element which has a value of 1 and is not visited. So it will be this. So here I did traversal, and then again here I'll do traversal, but will not be able to reach any cell. So my traversal will end where I start, and it will be added to visited. And then I will iterate over the grid, and I'll find another one over here, and I'll do traversal. And while doing the traversal, I'll add both of them to visited. And my answer will be the number of times the traversal is triggered. So over here we did traversal. mm, we did traversal here, we did here, and we had to do the traversal over here as well. So number of times we did traversal is 3, and that is the output. So yes, that is the basic idea, and uh, uh, it makes sense theoretically, but I'm sure you might be not very clear with how to implement this on the actual editor and code it through. So next up, I'm just quickly going to shift to my editor, and I'll solve this. I'll code for this solution and solve this example problem using the program. So we are going to together solve it and implement the solution so that we are crystal clear. So welcome to the editor. Over here, I have set up the entire example on my editor. The grid is as same as the one we saw on the whiteboard. And then we have the function find number of islands, and that we are going to code together. So let's begin by initializing a variable islands equal to 0. This will be our answer, that is number of islands. Then I'll define a function for breadth first search, and for now I'll simply pass. And for the parameter of the breadth first search, I'll enter q. Our q will be the input for the breadth first search function. I'll pass for now. And the whole idea was to iterate over the grid, find one which is not in the visited, and then do the breadth first search on it. So I'll be iterating of the grid. So to iterate over the grid, I'm doing I for in range of length grid, for j in range of length of grid 0. So that gives me the breadth and cross n dimension of the grid. And while iterating, I want to check if grid I comma j, that is element of the grid, is equal to 1, that is if it is a line. And also I want to check and also I want to ensure that it is not visited yet. So it should be a land and should have been our first encounter with that cell or with that coordinate. So I comma j tuple is not in visited. So when both of the conditions are triggered, I want to increment the island by 1, and then I want to do breadth first search on this coordinate. So I'll pass a q with only I comma j tuple as the only element to do the breadth first search. And actually, it makes sense that I do breadth first search first and then increment the number of island. In the coding aspect, it won't affect any much, but for just the sake of my mind, I'll move breadth first search above incrementing the islands. And yes, this function should return islands as the final output. So everything is ready. Just a couple of things are missing. Visited, we haven't mentioned it but used it. So let me define visited as an empty set, and it will be used in the breadth first search function, BFS function, and this function needs to be coded, right? So we will do the typical BFS programming that we've been doing for some time now. So the while loop, then v is equal to q dot pop 0. If v is in visited, I just want to continue with the loop. Then if it is not, then visited dot add v. For n stands for neighbor, so for n in the neighboring coordinates, I'll create an adjacency list right here. So what I will do is copy this and paste it 4 times because we have the 4 neighboring coordinates. So I'm going to paste it 4 times, and then +1 on the y coordinate for down, -1 for up, +1 on the x coordinate for right, -1 on the x coordinate for left. So we have all the 4 neighboring cells in this list, and now we are iterating over the list. So what I want to do is I want to check if I want to check if the coordinates are valid, right? I want to ensure that the coordinates are inside the grid. That is what I'm doing. So uh, the restrictions will be as these. Everything should be between 0 and the length of the grid for x, and for y it should be between 0 and length of the grid 0, zeroth element on the grid. that is n cross m dimension grid. Remember, it is not a square grid. So I want to continue when this happens, right? When we are in an invalid coordinate, I just want to continue and check other neighbors. Also, if the coordinates are valid, I want to then check what is at that coordinate on the grid. So I'm checking the element on the grid at that coordinate, and if it is equal to 0, that is water. So water is of no use to us. We cannot traverse it. So I'll just again continue and check for other neighbor. And if both of above two conditions are not true, what I will do is I will do the typical breadth first search. That is, I will check if the coordinate or the neighbor is not in the visited. If it's not visited, if it's our first time, I'll append it to the queue, and the breadth first search will follow for this when its turn will come. So I'll simply append the neighbor n to the queue. So it feels like everything is done. VS Code is telling me there is some error. I'll just figure it by running it. Okay, the colon is missing on this line, so I'll insert that and then I'll rerun the code. And yes, it shows that there are 3 islands found, and that's the answer. So the program works perfectly fine. And I just want you all to take a moment to look at the entire code as a whole and digest everything that we did. And if you need, come back and watch this video again, because repetition makes perfection.